All right, today we finished up our two-part series in solve exponential and logarithmic equations. So we did exponential, and now we're going to do the logarithmic equations. It follows the same pattern, and so basically we have one part is if we have the same base, log base a of x and log base b of y, it follows that just the x part, whatever we're logging, on the left side and the right side equals each other. Because if we do, let's see, what's the inverse of a log? Good, exponential. So if we do b to the log base b of x, again, we just took this and exponentiated it. And then we're going to make that an exponent as well. So b to the log base b of y. Then this right here is an inverse. And this right here is an inverse. So then we just get x equals y. So that's why we have that. The other part is when we need to exponentiate, which we'll do that. But let's look at this. So here's what you need to know. Right here, if you have the same base, then whatever you're logging equals each other. So if we had log base 5 of x equals log base 5 of 3, then the logs basically cancel out, and then we just get x equals 3. Okay, so that's how to do that. All right, so here, write this one down. All right, since we have the same log base 7, these cancel each other out. And so then we get 6x minus 16 is equal to x minus 1. A good question here might be, well, what if the logs are not the same? So what if we had log base 7 of something equal log base 6 of something? All right, in Algebra 2, that's not going to happen, so don't worry about it. All right, but that is a good question to ask right here. All right, so let's go back to our example. We want x's on one side, numbers on the other, so we're going to subtract x, and we get 5x minus 16 equals negative 1. So since I have my x's on the left side, I'm going to add 16. And so I get my numbers on the right side. And then we have 5x is equal to 15. Divide both sides by 5, and you get x equals 3. And then it's important to check these because if you remember when you are doing domain and range, for logarithm graphs, we can't have the log equal to 0, that asymptote. So if I plug 3 back in and check it, so on the left side I get log base 7 of 6 times 3 minus 16. And so that's going to be log base 7 of 18 minus 16. So log base 7 of 2, that's okay. I can take a log of a positive number. And then let's check the right side. So log base 7 of 3 minus 1, that's also log base 7 of 2, and I can take a log of a positive number. So this one checks out. Okay, so take a look at this one. What is the base of this one? Base 10, good job. All right, so they both have base 10, so we can cross those out, and we get 3x is equal to x minus 8. So since I have the numbers on the right side, and I'm going to subtract x from both sides, and I get 2x is equal to negative 8, and then I divide both sides by 2, and x is equal to negative 4. And then I got to check it. Right, because I can't take a log of a negative number or 0. So when I check, I'm not going to, let's see, we have log base 10 of 3 times negative 4. And that's going to be log base 10 of negative 12, which is no good. If I check the right side, I also get log base 10 of negative 12. So this is not a good solution, and since that's my only one to check, my official answer is no solution. Okay. All right, because if you think of the log graphs, they go like this, something like that. And so we can't cross, logs can't be 0 or negative. Right? Okay, so let's look at example 2. We've got log base 5 on both sides, which means these cross out. And then I just get 4 4x minus 7 is equal to x plus 5. So if you can do this all by a lonesome, go for it. Pause it. Hopefully you paused it before that, though. All right. We subtract x, we get 3x. We add 7 to both sides, get 3x equals 12. Divide both sides by 3, and x is equal to 4. All right, so let's check that, make sure that's a good solution. So log base 5 of 4 times 4, because that's my x, minus 7. And so that's going to be log base 5 of 16 minus 7, which is the same thing as log base 5 of 9. So that's okay. We can take a log of a positive number. And the other one, likewise, is going to be 4 plus 5. And that is also log base 5 of 9. So those check out, so this is a good answer. All right, and then this one, let's see. We don't have log base 5 on both sides, and I can't add log base 5 to the right side because I got to keep it balanced because it's an equation. So let's see, what could I do? Oh, I could read the side of the board. All right, so what gets rid of a log? Exponent. Good job. So we are going to make the left and the right side exponents, just like we did for inverses. But what is my base? What is my base going to be? 5. Great job. All right, so we're going to do 5 to this power. So please, pretty please, write the log base 5 as an exponent. That's going to help, right? And then we also need 5 to the right side, so 5 squared. Okay, so this became an exponent and this became an exponent, right? So make sure you show all your work, very important. All right, so this is an inverse, so that goes away. And so on the left side is 3x minus 8. On the right side, 5 squared is equal to 25. Okay, so don't forget about that. All right, that 5 does not go away. All right, so now I've got an algebra 1 problem, so I'm going to add 8 to both sides. So I have 3x is equal to 33. Divide both sides by 3, and x is equal to 11. So when I check that, I'm just going to make sure that when I plug in 11, I'm not taking a log of a negative number. So I have log base 5 of 3 times 3, no, JK, 3 times 11, because that was my x, minus 8. So I have log base 5 of 33 minus 8, which is 25, and that's okay. So this is a good answer. X equals 11. All right, so this one is example 4. I guess I really want you to know that. Is example 4. See if you can do this all by your lonesome. Pause it, see, work it out. If you've got this, you've basically got it. There's only one more tweak. So pause this, fill it out. Okay. We don't have logs on both sides, so I want to get rid of the log. So what gets rid of a log? Exponent. Good job. So we're going to exponentiate both sides. What's our base going to be? What could our base possibly be? Oh, 4. All right, good job. So we're going to do 4 to the right side. So all of this becomes an exponent. Log base 4 of 5x minus 1. So write it as an exponent, please. And then the 3 becomes an exponent with a base of 4. Okay, so 4 to the right side equals 4 to the left side. Now, do you guys recognize the inverse? Circle the inverse. Good job, right there. And so that goes away, and we have 5x minus 1. And then 4 cubed is 4 times 4 times 4, so that's 64. And then I add 1 to both sides to get 65. Divide by 5 on both sides, and x is equal to 13. So if you did that all by yourself, great job. And then we're going to check it. So we're going to have log base 4 of 5 times 13 minus 1. And so that's going to be log base 4. Let's see, that would be 65 minus 1, so 64. So it's definitely a positive number, so this number is all right. Okay, and you can actually, if you did the half smiley face, you could figure out that that was 3 and double check. Okay, So here, you try this all by yourself. So if you watch me for the first two, try this one all by yourself. You can do it. Pause it. All right, so hopefully you are just watching this to make sure that you did it all by yourself. So please try it, pause it, you can do this. We are going to do 3, because log base 3, so the inverse of log base 3 is 3 to some power. This is going to be my power, so log base 3 of 2x plus 9 is equal to 3, and then this is now going to be my power, 3 to the third power. Okay, so square, circle the inverse. All right, hopefully you did that. And then we have 2x plus 9 is equal to 27, since 3 times 3 times 3 is 27. So then we subtract 9 from both sides, and we get 2x is equal to 18. Divide by 2, and x is equal to 9. All right, and if you checked it, great. So when we check it, we're going to do log base 3 of 2 times 9 plus 9, and that is going to be a positive number, so that's okay. So 18 plus 9 is 27, so that would be fine. So x is equal to 9. All right, we have one more tweak, and then you guys should be okay. Actually, well, a couple more tweaks. All right, write this down. And then we need to get the log base 4 by itself before we exponentiate it. So what do we need to do to get log base 4 of 10x plus 624 by itself? Good, divide by 5. So let's divide by 5. Whatever we do to one side, we do the other side. So what we have left is log base 4 of 10x plus 624 is equal to 5. All right, so now it's just like the other 3 examples. So pause this, do this all by your lonesome, and then check back with me later. All right, so what do we have to do to one side? How do we get rid of the log base 4? 4 to some power, great job. So we're going to do 4 to this side, and then my exponent is this. So we have 4 to the log base 4 of 10x plus 624. And that is equal to 4 to the other side, which is so 4 to the 5th. Okay. All right. So we've got all that in place. So do you recognize the inverse? Right here. Awesome. All right. So now we have 10x plus 624 is equal to some crazy power. So 4 to the 5th is going to be 1024. And a good question would be, is this 4 to the 5th going to be on our test? And it's not, okay? So you'll have things that you can do all by your lonesome without a calculator. All right, so we subtract, we get 10x is equal to 400. Divide by 10 on both sides, and x is equal to 40. And if I plug 40 in for my x, I will get a positive number, so this number is okay. All right, if you did that all by yourself, great job. All right, now look at this one. Log base 2x of log base 10 of 2x equals log base plus log base 10 of x minus 5. So how do we do this one? I can't exponentiate all of that because of the plus sign. That would be illegal in Algebra 2. So is there some way that I could write 2x and x minus 5 into one single log? I just want one single log with base 10. There's some way to combine 2x and x minus 5. Oh, we could condense it. Good job. We can condense it. So how could we condense that? Multiply. Awesome. All right, so we're going to do 2x times x minus 5. And that's going to be equal to 2. Okay, so let's see. We can distribute this a little bit more. So we are going to get log base 10 of 2x squared minus 10x equals 2. Okay, so we have that. All right, now how do we get rid of the log? Good, we're going to exponentiate. What's our base going to be? 10, awesome. So we're going to do 10, and all of this becomes an exponent. So please write it as an exponent. Log base 10 of 2x squared minus 10x is equal to, and then whatever do the one side, we have to do the other side. So 10 to the power of 2, so 10 squared. And then do you guys see the inverse? Here's the inverse. So on this side, we get 2x squared minus 10x is equal to 100. All right, so now we just solve. It's a quadratic, so I want to move everything to one side. So I'm going to subtract 100 on both sides. So I have 2x squared minus 10x minus 100 is equal to 0. And then I want to factor that or use quadratic formula, but I notice they all have a common factor of 2, so I can divide everything by 2. All right, so we've got x squared minus 5x minus 50 is equal to 0. All right, so now I can factor that or quadratic formula. Let's see, 50 is 1 and 50, 2 and 25, 5 and 10. X is 1x and 1x. All right, so I think these will do it. Negative 10 and a positive 5. So my factors are x plus 5 and x minus 10 equals 0. Am I done? Oh yeah, I have to solve for x. Okay, so x is going to be equal to negative 5 and x is equal to 10. Am I done now? I have to check it. You're right. Okay, so when I have to check it, let's see, what was my very original one? Log base 2. Sorry, log base 10 of 2x plus log base 10 of, we'll go slow this time. All right, x plus 5. X plus 5. Okay, equals 2. So if I plug in negative 5, am I going to get taking a log of a negative number? Or 0? Okay, yes, right here, if I plug negative 5 in, I'm going to take a log of a negative, log base 10 of negative 10. That's not going to work. And if I plug negative 5 into here, I'm going to do log base 10 of 0. So both are highly illegal. So negative 5 is not going to work. What about 10? Well, 2 times 10 is 20, so that's okay. And 10 plus 5 is 15, so that's okay. So my answer is just x equals 10. All right. All right. More. So you guys try this one. It's the same exact thing. You can do it. Pause it, try it by yourself. You can do this. Okay. All right. And then fast forward to see if you got your answer. All right. So we want to condense into one log. So let's see. What is plus in condensed land? Multiplication. All right. Good job. So I'm going to, oops, not plus 9. JK. All right. That's going to be x minus 9 equals 2. And then how do we get rid of the log base 6? Right, 6 to the left side. So 6 to the log base 6 of, let's see, I can distribute that. X squared minus 9x is equal to 6 to this side, so 6 squared. So this became an exponent and this became an exponent. All right, do you guys recognize the inverse? Hopefully right there. So that's the inverse. So I just get x squared minus 9x equals 36. And then I'm going to subtract 36 from both sides. So I get x squared minus 9x minus 36 equals 0. All right, looking for something that subtracts to negative 9. So 1 and 36, 2 and 18, 3 and 12. There's 6 and 6, but I think I found it. So if we have a negative 12 and a positive 3, that would work. So I have x minus 12 and x plus 3 equals 0. So x is going to be equal to 12 and x is going to be equal to negative 3. And then I got to check them. So my original was log base 6 of x plus log base 6 of x minus 9 equals 2. All right, so if I plug 12 in, that's okay. And then 12 minus 9 is 3, so that's okay. So this works. Negative 3, if I take a log of, if I just plug in negative 3, that does not work, and it doesn't work on the other one. So that one is not a solution, it's just the 12. So if you got the 12 all by yourself, great job. You can totally do this. All right, so here's the guided practice. The first six are from the video, not in the book. And the minus signs, what does minus mean? Look at 5 and 6. What do minus signs mean in condensed land? Division. Good job. All right, so you're going to divide. And then 7 through 10 are from the book. All right, so good luck, and I will see you tomorrow.